Good afternoon, Ayush.
Hi, good afternoon.
Shall we start or we shall wait for 5 more minutes?
Uh, Whatever you say, ma'am, we can wait for 5 more
Okay.
minutes.
Okay, so we'll wait for a few minutes and then
Yeah.
maybe start. Okay. So Ayush, I'm thinking that we shall start and the participants will join the way. So, for all the participants, let me give a brief introduction of Mr. Ayush Singh to the audience here. So, Mr. Ayush Singh is a dynamic and talented person working in as simulation engineer at Integrated Microsystems, and with a strong background in mechanical engineering and computation simulation, he brings valuable insights into advanced modeling workflows and their practical application in real-time research environment. And today he will be guiding us through hands-on technical session and sharing his rich knowledge in image-based 3D modeling. So let I extend a warm welcome to Mr. Ayush Singh from Integrated Microsystems and look forward to an insightful interactive session. And I once again welcome you, Ayush, and I'll ask my participants to please ask any question on the way. If you have any query, please ask him and please note it down. We can solve it in the second half or we can solve it whenever the time allows. So please continue, Ayush.
Sure. Very good afternoon, everyone. First of all, I would like to begin my expression, my sincere gratitude to the dignitaries and faculty members of NIT Jalandhar who made this workshop possible, and a very special thank you to Dr. Pernika for giving us this opportunity for her support throughout the coordination. A quick introduction about myself. I am Ayush. I am an application engineer at Integrated Microsystems. I focus on medical image processing, simulation, and advanced modeling on the tools like Synopsys Simpleware, Elucys XR, by Realize Medical. So I have a general uh, idea about how the 3D image processing work, how the simulation sector works while we are doing the image-based modeling. Also, I have had the opportunity to work closely with researchers, clinicians, and professors across premier institutions like IITs, NITs, IIScs, and organizations like DRDO, SSPL. My role involves delivering technical support, training, and workshops on converting complex 2D medical image data into 3D models for analysis, 3D printing, or simulation. I am excited to be invited in this session to deliver my insights how and what are the capabilities of Simpleware where it can be used to bridge the gap between imaging and simulation. So with that, let us start with our session on 3D image processing using simple Synopsys Simpleware software. So here's a brief intro about the company that I work for. So Integrated Microsystem has been dealing in EDA tools, electronic development tools for close to 20 plus years. And we have been delivering out the technical sessions and all the commercial support to clients across India for Synopsys Simpleware software for past 10 years. Our clients are majorly focused from ITs, NITs, and EAMS for the Synopsys Simpleware software. And apart from Simpleware, we also provide other electronic based simulation software like Quantum ATK that is developed for nanomaterial nano device modeling. And we also have plethora of new softwares to be included in our portfolio, such as Synopsys XR, where we can do the VR based segmentation using the VR headset. That I shall be focusing on the last day, that is the day 5 of this workshop. So, a quick overview of the session. Here, what we will cover over the next hour is first I'll introduce the basic of image processing and explain why the 3D image processing is important, especially in biomedical fields. Then we'll have a look how medical images are acquired and how these can be converted into 3D models. I'll also introduce how the Simpleware software suite and what are its key modules that can be used for our setup workflow. Then finally, we'll go through some real world applications and use cases, and I'll give a quick walkthrough on how to use this high level tool in a very simplified way. First of all, there must be a question among all the participants who are not familiar with 3D image processing or 3D modeling that what is this? What is the 3D modeling? What is image processing? So image processing is basically a technique that is used to analyze, enhance and extract useful information from images. In the medical field, it means taking 2D image slices from a scanner and working with them to identify the features of interest. Like if we are much more uh, into the bones, organs, or tissue, so we can work on the specific part. We can segment that particular part out and work on our specific region of interest as desired. It also allows us to isolate and enhance specific anatomical structures, removal of noises, as any CT data, any MRI data that we will be coming across. It will be having a lot of noises within it. And we need to eliminate the noises to have the most accurate and the most precise structure segmentation for our set of workflow. Also, this ultimately helps us while we are doing any simulation based task. So, for example, how good is our segmentation ultimately results in how good is our simulation. Whatever FE model, that is finite element model, that since all the participants I think are from mechanical field, so must be aware about the finite element modeling. So to develop a high quality FE model from medical image data, there is a requirement of high quality 3D imaging. And how that we achieve is we have several procedures to work across the image data set. We have certain operations that can be carried out first to visualize the data set and later on convert into 3D printable models or else 3D other 3D formats such as for ANSYS, Abacus, we can export the particular files for doing the simulations. It is a foundational step in creating accurate 3D reconstructions from the scanned dataset, which involves the image processing, where we apply various sets of reprocessing platforms, such as cropping down to a specific region of interest. Then we also have the option of resampling the dataset. So if our dataset is quite large, it generally doesn't happen in the case of medical dataset, but when we are dealing with any industrial grade dataset, for example, doing the reverse engineering to compute the dataset. So we have an option of resampling the dataset so that we can reduce the dataset size of our system. The next part involves the segmentation. Once any pre-processing operation is performed, like resampling, cropping, morphing of datasets, aligning the structure, then changing the dataset size, or even rescaling if required in any case. Once these particular stages are covered, we move on to the next part that being the segmentation. In Simpleware, we are provided with three modes of segmentation, namely manual segmentation, semi-automated segmentation, and live segmentation. In Simpleware, we are provided with three modes of segmentation, namely manual segmentation, semi-automated segmentation, and the last we have the automated segmentation. And the last we have the automated segmentation where it is actually built on pre-trained data set and it automatically segments out the data according to our specific requirement. For example, if we are taking a pelvis CT data set and we need to segment it out into left right femur, left right hip and sacrum. So the software can be told which part we are interested in. We can highlight that particular region, and we need not to do any manual task. We just need to click on a single click apply operation, and it will do the segmentation task for us. It helps us a lot while we are working with the data set. It also reduces the as it reduces the turnaround time by significantly. The next part, when we complete out the segmentation and the model generation capabilities, a model generation capabilities that can be either exported out directly for the 3D printing in a form of 300 file, STL file, or even the OBJ file. But what if we require a high quality 3D meshed model? So for that, we have a complete support in Simpleware. We have the FE modeling tab. Here we are supported with different grid algorithm. So according to our use case, we can use the different sets of algorithm and ultimately do the particular final model prepared. We can export in multiple simulation software. For example, COMSOL, Abacus, ANSYS, and since ANSYS is already being acquired by Synopsys. So in the coming stages, we can also see a collaboration directly within a single tool range where we can be focusing on a streamline on performing out the analysis in ANSYS software. So, and apart from this, there is one more type of model that is terms model generation. NURBS basically stands for non-uniform rational replacement structure, wherein we can develop high quality CAD files like STEP or IGPS. So whenever we are integrating the data set with any implant data set, these particular files, it is of very much use for us. So for example, if we are integrating the data set with any implant data set, it streamlines our workflow. It streamlines our workflow. And once we are computed with this model generation, then the meshing, we move on to the next huge topic to be covered because it involves several steps, right from the measurements, the wall thickness to image measurements, then the central line network measurement, then the surface area measurement, volume measurement, any volumetric data measurement. These all are included in the reporting layer. It will be further showcasing in the further showcasing in the second session when I get to considering any CT data set that is computed tomography data set. It has the orthopedic region. It may also have many soft tissues, blood vessels, and dealing with this data set. Different density. A soft tissue will have a different density, and any arteries and all set of densities. And these densities ultimately, when we are using a CT scan, will be divided into a grayscale value range. We can use the particular grayscale value to identify different region and work on the specific part that is required. This multi-scale modeling is of very much use for us. For example, if we need to learn about anatomy, so it can be done in a very useful way. If we have a whole CT data set of from full body CT data set, so what we can do is we can create a 3D printable model and we can replicate exact physical dimensions of the body of any patient from which the data has been taken from. It also ensures that we get very high accuracy as it is just the replica of patient and it generally works on any patient data set that we are interested in. Also, while we are dealing with 2D slices, it may give valuable data, but it can't provide processing. We can visualize the anatomy in 3D dimension, and thus we can enhance our understanding of the anatomy as well as when we are doing any sort of model creation. For instance, if a surgeon is planning an operation or a researcher is simulating any blood flow, he needs precise 3D models for the same. And the transformation also helps in creating patient-specific devices, running simulation in FEA tools, or even printing the anatomical replica. That's why 3D image processing is very important. Because to define any material, for example, if we are thinking of developing a new set of titanium material, and we need to check its accuracy. Now, what are the different scales and models? So there are basically the first one in macros that being present in our body or even the medical devices if they are present. For example, if we are mapping out a femur, so it comes under the section of macro scale. And but when we are dealing with small tissues that are present inside the particular bone data set, so it will come under this micro scale where it will carry. It will also have the properties of the material that has been used and be able to see from the naked eye, or even when we are dealing with any simulation software, if we are unable to see the surface features, we can also check the internal structure of the same. So this way, a micro scale CT can be worked on. So CT data set are divided into two sectors: micro CT and macro CT. So macro CT involves a full body CT scan that is used basically for medical data set, and micro CT generally works for material image processing. And this material image processing is very important because to define any material, for example, if we are thinking of developing a new set of titanium material, and we need to check its accuracy, how it will behave, how any wear and tear will happen over a period of time. So to have complete overview how the implant would work in a patient, so for that we can completely rely on such software like Synopsys or Simpleware to have a complete overview how the implant would work in a patient, and at what time will be the fracture point for that implant, and at what time will be the fracture point for that implant. So we can see the bone structure that is generally not dealt in, and see the nanoscale features. So to develop any specific part, we can do that in the micro scale and the macro scale in Simpleware or any other image processing software. But to deal with any nanoscale structure for image processing, we need to rely on the micro scale. Now, what are the different application software? There are open source platforms available. So to simplify that, there are open source platforms for any software that we are working on. But we need to have a complete knowledge about image processing. Also, we need to completely understand the need of the software. What this particular software does is it provides us different sets of segmentation algorithm combining different sets of implant positioning tools, greater insurability and compatibility with different connecting softwares like SolidWorks, for example. We have a designing tool present within the Simpleware. So if we are having an active license of SolidWorks, we are planning out any implant design that we are carrying out SolidWorks, we can visualize the data set in Simpleware to the particular segmentation algorithm. All this possible, and these features are limited when we are using any open source software. Apart from that, there is also a need to develop high quality and accurate anatomical models. Since we are dealing with patient specific data, and we are dealing with patient specific software, and we need to have a full data set, and it will be used for clinical researches, and it may also be used for surgical purposes. So we need to have a full we need to ensure that the particular model, one more advantage that it caters is it reduces the time. So I have tried it myself. I have worked on open source software, huge time when we are doing image processing. We are doing it in 3 hours in any 2 to 3 minutes using high-end tools like Synopsys Simpleware software. Also, there is a reduction of errors, and even if there are small bugs that are present in software, so it generally gets removed with the next release that we get. So this way, it is very much useful for us. Also, when we are dealing with any multi-system environment, in that case also we need to use simpleware. And the other part being any modeling capabilities. So since we are fully compatible with developing any sort of finite element model, CFD model, NURBS model, it eases out our workflow and a better understanding of how the particular workflow will work. Now, coming on to the Simpleware software range and what is actually Simpleware and how it can be used for. So, Simpleware is a powerful software suite that is developed by Synopsys, and it is basically designed specifically to convert 3D image data into usable models. It handles everything right from importing DICOM images to segmentation to generation of high quality 3D images using which are very suitable for simulation of 3D printing. The biggest advantage is it makes this entire complex pipeline user friendly, even with those who are without a programming background. So, if we are just familiar with the GUI, or any naive user can understand the software within 2 to 3 days, from converting the DICOM dataset to converting out a 3D printable model, or also if required, he can do the particular question in the chat box. Yeah, morning we can get it. Yeah, so porosity analysis is possible. That I shall be covering out in the third day. How to do various sets of analysis in simple way. What are the different measurement tools? But I'll be giving a brief about how what are the different tools that are available, and to work on the detail, we'll be covering out in the day 3 of this workshop. But it does has a porosity analysis. So even for any complex phones we need to check out, we can check the porosity as compared. So now coming back to the Simpleware software range and how we are working on it. So we generally start with any CT or MI scan, then we do the pre-processing while we are working. Next comes in the segmentation where we label, isolate specific anatomical features. We have used various sets of operation like bone filling, cavity fill operation to solidify the bone part. And later on, the result can also be visualized in the 2D images. So we can cross-verify the data set. Also, we can highlight it over any specific volume rendering to check for its accuracy. Now, coming on to the basics of medical image segmentation. Basics of medical image segmentation is quite important to learn about the tool. So let us look. First up, we have the scan IP. That is the core image segmentation module where we captures. Also, a volume rendering is one such feature that I surely rely on when we are dealing with complex data set cases. Then there's plus FEM model, so that stands for finite element modeling and computational fluid dynamics modeling, wherein it allows us to generate simulation ready meshes and export them to finite element analysis tools like ANSYS or COMSOL that can smooth surfaces models, and it also allows us to import or merge with mechanical components like implants. And these all modules are basically combined as a single bundle for academics. So whenever we provide the software for any academic purposes, all the particular different modules that we are naming are combined in a single bundle, and it ultimately enhances the efficiency of the same. Now coming on to the different 3D image modeling imaging modalities, we have the CT scan. That is computed tomography scan that we use generally for bone, and high density materials. So use different sets of imaging modalities depending on our. X-ray will provide us a 2D image based approach for any data set. Then we have the CT data set to visualize any bone component and to basically see for any structure. Then we have a micro CT that is generally used for developing any small structures or samples that are generally needed for industrial purposes. Now we can see in X-ray we can only see the 2D view. So a surgeon or any clinician also can't do much with this data set as it is having a single side view. And to understand this, if we are seeing a cuboid, it's a 3D object. But if we are only able to see one single face of the cuboid, so we will be just seeing a rectangle. And if someone is asked what is this, if a cuboid is shown in a 2D view, so he will say it is a rectangle. But in fact, if we are seeing a front on view and we are seeing a rectangle, so it won't give us a proper knowledge and it won't give us a proper understanding. And our interpretation would be wrong about the data set. So since high-end tools or means imaging comes in place, when reconstructive corrective surgery is required, in any preoperative planning is required, it can be done at a high accuracy and high efficiency. Then we have this magnetic resonance angiography, then we have types of scans that are available, and depending on our workflow to workflow, we use different set of modalities. For example, to highlight any soft tissue, to have the soft tissue visualized, we use a proper structure creation, a 3D model creation, a 3D printable model creation. We generally rely on this computed tomography scan. So whenever we are doing the image processing, the first step is always the data acquisition and import. First, in Simpleware, we have a huge range of image modalities to be imported. So, right, ranging from DICOM, where we can import CT, MRI, micro-CT. We also have any raw images, any BMP images can also be processed, analyzed, interfile, meta images to have a quick overview. And not just that, even if we are having a volume mesh file in ANSYS, Abacus, COMSOL, VTK, we can import that too in Simpleware and do the reverse engineering of the same. So we can import image data right from the volume mesh file if we are having so. And apart from this, we have the standard approach of STL and CAD file. So even if we are having any STL, that is stereolithography file or a CAD file, we can bring that in Simpleware software, work on it, do any modifications if required, as we have a separate surface tool that is specifically dedicated for that. Apart from this, whenever we are importing the data coronal, sagittal, axial in the case of, so the bone it's just a volume rendering, and this segmented uh, region that we can see. So this is done using auto segmentation tool for spine. Here it basically segments out the vertebra from sacrum and it renames the falling also. So it renames the vertebra as V1, V2, V3, V4 and so on. So it will rename the vertebra, it will highlight the sacrum. So if we need to work on any lumbar spine, so I can just isolate the particular region. I can work if I am developing an implant for the specific region, we can do that, and it ultimately eases out our workflow. Apart from that, we have quick reviews. So to check whether our accuracy of segmentation is good or not. Sorry. So to check whether the accuracy for our segmentation is good or not, is any section that we are working on on how the quality of the particular section can be improved. All is possible. We can just adjust the quick previews that we have in the volume rendering settings. For example, for bone, we have a different volume rendering setting than for a soft tissue. We have a different volume rendering setting. And depending on the noise, recursive Gaussian filter was used to smooth out this structure. So let me magnify this particular slide. This I'll also later show in the particular live demonstration of the tool, wherein we can work on uh, we can directly show we can work on any specific design that is required if any of the participant is working on such data sets. So taking the following example, this was a sticky data set of a fractured mandible that was imported over here. So it was a CBCT scan, that is cone beam computed tomography. Generally, when we are dealing with any dental data set, it comes in a CBCT form. And whenever we are working with a CBCT data set, the major issue with that data set is it has lot of noises, and we need to eliminate the noises to have an accurate model simulation. So for that, in this smoothing filter, we are given with five types of smoothing filter. The first one being recursive Gaussian, then we have the mean filter, median filter, then we have the smart mask smoothing. Generally, for medical cases, we recommend using a recursive Gaussian, a median filter, mean filter, or a smart mask smoothing filter. And here, whenever we are working on this particular part, so what we do is we set out the target value. So for this, it was taken as 2 in x, 2 pixels in x direction, 2 pixels in y direction, 2 pixels in z direction. Once this particular operation is applied, so we can see the reduction of noises, and it has eliminated almost all particular noises that we were able to see. And once we obtain a proper understanding of data set, then the segmentation also becomes quite easier for us. And not just the segmentation, to just for example, even if we are not requiring any sort of segmented model, but we need to see the structure and preserve the anatomical accuracy. So these particular noise reduction techniques play an important role for the same. So this is one such way that we can work on. The next up is the segmentation fundamentals. I think there's a question in the chat box. Yeah, so this is a very good question, that how this can be selected. So since I've used a recursive Gaussian filter, and it's generally recommended to use a value between 1 to 3 when we are using this recursive Gaussian filter, because when we increase the value from 3, it might start distorting the image that we are working on. So to keep the anatomical accuracy in mind, it is generally recommended to use a value between 1 to 2. And if even if there are 2, we can increase the value, but not at all recommended. So I hope that answers your question. Yeah. So continuing up with this presentation, next is the segmentation fundamentals that we have. So as explained in a couple of slides earlier, that we have different modes of segmentation in Simpleware. So we have the manual segmentation, we have the semi-automated segmentation, and then we have the fully automated segmentation. In the manual segmentation, these are the old primitive tools that we used to like the paint and paint with threshold, wherein in corresponding to any view, coronal, sagittal, and axial view, we used to work on the specific parts. And once we were working on the particular specific parts, we needed to highlight the region. So let me take a laser pointer. Yeah, so this is the paint tool that we used to work on, wherein we needed to work on each and every slices, and it used to take a huge amount of time just to do the segmentation. Then came up a threshold based approach, wherein there is a threshold grayscale range ranging depending on the data set to data set. Generally, for medical uh, CT, for a bone CT, it has a value from minus 1000 to 3070. And it also ranges from data set to data set. If we change the particular image modality from a 16-bit data to 8-bit data set, it is generally reduced down to 0 to 255. So the grayscale is remapped for our specific dataset workflow. Now, in the threshold-based approach, we are also given with certain pre-segmented algorithm. So in Simpleware, it offers different set of options. So we can create our own sets of presets. So if our majority of workflow depends on only bone city data set, so we can set out that this is our city machine settings. This is the particular general grayscale range in which majority of the bone structure lies, and the software will automatically detect that and does the segmentation for us. So that is comes under a semi-automated segmentation. And the threshold, apart from threshold, we also have an advanced tool option that has multiple semi-automated segmentation. So we have a watershed algorithm to segment out any structure. Then we have a multi-level also segmentation, and we are also having an advanced input segmentation that we can use to semi-automatically segment out the anatomy. And the last we have is the fully automated segmentation, wherein for orthopedics we have it for ankle CT, knee MRI, hip CT, hip revision CT, shoulder, spine, craniomaxillofacial. For cardiovascular we have heart CT, heart valve analysis, and the best feature that we have got in the latest version release, that is version 2025.06, is the inclusion of external models. So earlier on, there wasn't any option wherein we can import our own set of segmentation algorithm to check for its accuracy. Now, it has been accomplished in the latest version release, wherein if we are working on we have created our own set of segmentation algorithm. We need to check its accuracy with the standard that is available in the market. We can complete out that using the external models. Not just that, even if we need to use any other segmentation algorithm like total segmenter, 3D slicer, or NVIDIA models like Monai models for doing the segmentation, we can bring out the dataset from these models. We can apply that in uh, Simpleware and do the auto segmentation for us. So even if there are certain anatomies like for a liver segmentation or kidney segmentation, we can work on data set. And then we also have a dental segmented if we are working on any specific dental data set. So we can use that as an external model. I am not discussing in detail about the auto segmentation module right now because in the tomorrow's session, Pratik would be covering out this auto segmentation, how it provides a complete workflow for the same, how we can do the import of any data set. This all will be covered out in the next session. It's just a brief of about what we are going to cover. Now, there is also an option of generating a manual segmentation and AI-enabled segmentation. And I'll tell why. Mixed approach is always the best approach. So this was the data set that I was working on. So the particular patient's data set, I can't disclose the patient's name, but the data set was given by Ames Delhi for us to do the segmentation and create out a 3D printable model for the same. Why it was required? So it is now we are coming on to the real world applications wherein how the software can be used commercially. So the doctor required it for detecting a VSD defect, that is a ventricular septal defect. Ventricular septal defect is basically a hole in the wall of heart. So when there is a hole that is created between left ventricle and right ventricle, and doctor needs to fix it up, but he is not having a proper visualization using a old approach that is using directly a CT MRI. So what he suggests to the patient is get a 3D printable model for us, a hollow structured model. So it is, you can see it is segmented out into three different parts. So these parts can be separated out, and a particular surgeon can visualize the internal structure. So what I was saying is the manual versus AI segmentation. So this particular task was done using manual segmentation, and you won't believe it took around 4 hours to do the manual segmentation. The data had too much noises. It had certain structures that were missing. Then we thought of why not to switch for an automated segmentation algorithm. So when we worked on that automated segmentation, it provided us the solution within 2 to 3 minutes, but still some parts were missing. So what I did was I did a combined approach. So the combined approach took around 10 to 15 minutes to do the segmentation. What we had done is we had just done a threshold based operation, a general segmentation for that, and then we had done an auto segmentation. And then we have marked the different regions that were present. So we have marked the aorta separately, left right ventricle separately, right atrium separately, left atrium, pulmonary artery. We have marked all the regions using the auto segmentation, and the output that was delivered in 15 minutes was the best output that I had seen from across cases that I had worked on. So I had worked around 50 plus cases for similar hard data set only. And apart from this, we also do code modeling and all. So we provide technical support to clients across India. So over there, this was the best approach that we have got. So what we have done is we have used a mixed approach. So we have done some part using manual segmentation and some part using automated segmentation. And then we have basically combined the data set result to have a proper overview of the same. Now, this was the medical aspect, and in the coming slides also I'll tell about some more medical aspects. But there is also a need to understand what are the software capabilities beyond biomedical image processing. Since participants are from mechanical engineering, so mechanical engineering sector, so they must be familiar with CAD-based approach, and even working on computer aided designs are familiar about different parts that we design. And one such operation that we perform is doing the reverse engineering. So to check for the accuracy or to do any quality inspection to check for any metrology defect, that is the most important thing uh, in which the software can be used on. So whenever we are developing a CAD file, and when we have done the 3D printing, what approach that we get is generally when we are doing the designing of CAD part and we have done the printed, so some surface might not get included while we have done the 3D printing. To check for that accuracy, what we generally do is whatever is the 3D printed part, we rescan the part. Once the rescanning is done, we again bring that in Simpleware software. Then we have an overlapping feature. So that is a surface deviation calculation. So we overlap the CAD design that we have designed with any tool like SolidWorks. We overlap it with the scan dataset to check for any surface deviation and corresponding to which point the surface deviation is the maximum. So that in this way we can ensure the particular segmentation that we are generating is a high quality segmentation without any error. Apart from it, when we deal with this reverse engineering, that there is one more aspect that earlier on we used to rely that we can only capture the external surface detail using a 3D scanner, handheld 3D scanner. But the other approach that we have is what we can do is we can scan the data set using a micro CT scanner, so we can check out the internal features. And internal features are the most crucial part while you are working on the reverse engineering aspect. For example, taking an example of pipe. If the pipe is looking very good from the outside, but it has certain holes or gaps present in the internal structure. So we might not be able to just visualize that from a surface scan. So we need to check for the internal structure that can be done using the softwares like Simpleware. So these are applications in the field of engineering. This will be completed in detail in day 3 of this workshop, where we will be discussing the engineering aspects of Simpleware. Coming back to biomedical followed by engineering aspect. So the hollow part that we have discussed in one slide earlier, the printable model that we have developed using Simpleware. So this was how different parts look while we were developing in Simpleware. Once this was done, we had done the 3D printing of the same. So this is a hollow structure that we have developed. Here is the particular VST defect that can be seen. So let me mark. So this was the VST defect that could be observed, and through this, so the particular surgery was performed, and the outputs that we got from that surgery was quite magnificent, and the accuracy was very high since we are dealing with any patient specific data set. And it's not just limited to this heart. Even if we are doing any prosthetic design, so what we generally get is general implants that are present in market are not patient specific. And the issue with such type of implants is we might not get proper accuracy while we are working with that particular part, because every patient is different, every anatomy is different, and to have a greater implant positions in our body, we need to develop the particular patient-specific implants for better accuracy and for less wear and tear over a period of time. So that can be done using softwares like Simpleware, SolidWorks, combining the both approach and working on this same. Now coming on to some more use cases and how this particular is using for any pre-surgical planning. So I have taken this particular from a research paper that was published by Coronum. So they have used a Simpleware software. They had scanned the dataset. That's a femoral cage that they have developed. So this particular patient also had an acetabular defect in which the particular acetabular cap was cracked. So they need to replace it using a titanium cap. And then later on, the fixation was also done for a femoral. So this was a total hip replacement surgery that was performed. The particular parts that were printed were titanium ELI 24 grade parts. So that is high quality of implant printable material that they had used. They had developed a 3D anatomical model from the patient scan. Then they have planned and simulated surgeries virtually. And ultimately, the custom fit implant was designed and assessment was done. Why I have shown this paper is because the particular patient had earlier gone with the same surgery, but when the particular surgery was performed earlier on, no such virtual planning was used, and the implant got torn within 6 months of use case, and the patient had immense pain, swelling is in uh, abdominal region and the hip region, so he required a pre-planned surgery for the same. So then the doctors met with the Simple team how this can be done, and later on the 3D scan was done. Since CT scan was already available, a new scan was done in which it also had the pre-positioned implant. The particular surgery was reperformed, and then the outcome that he got after a particular patient-specific implant was designed was tremendous, and the accuracy was reduced. The accuracy of implant failure was reduced by a significant region. And how they were able to check the accuracy, whether it will be getting wear and tear over a period of time was once they have done the segmentation, they have done the modeling. The next approach that they required was to simulate the same in any simulation software. So they have used ANSYS to simulate whether it will cause any wear and tear over a period of time, and they checked that it will take around 15 to 20 years. That's more than the standard time that is for the implants failure that we generally get. So that's a huge amount of time that they got, and now patient was relieved from the pain that he was getting. So this is a very important approach that we need to understand. And why this particular session is important for mechanical engineers is they are the only person who can bridge the gap between mechanical engineering and the surgical planning. Why so? Because any mechanical engineer is familiar with computer-aided design, they are familiar with SolidWorks software or other CAD designing software range. And to learn the Simpleware software is a little bit easier as learning any CAD designing software. And once a particular CAD engineer operates on Simpleware, they can be exposed to a wide range of possibilities in the career terms also. So they can work as a biomedical engineer, they can have work as a surgical guide planner, and there are various career options that further can be catered to. So this is very much important also to deliver a better accuracy to the patients and to ultimately improve the living standard of living for any patient. It's the most crucial step to work on a patient-specific data set. Now, coming on to the simulation integration, since I had explained earlier that we have the capabilities of generating out mesh, so we can generate high quality finite element meshes, we can select out the elements, contact pairs that will be covered in the tomorrow's session, where we will be discussing the finite element part and the CFD part using softwares like NC Abacus. What I'm trying to say is we have the option of creating boundary condition. We can do the particular mapping, and not just that. Whatever mesh that we have created in Simpleware, we have the option of not remeshing it in any ANSYS software, Abacus software. We can directly create the ANSYS file, .cdv file, .inp file, and the simulation can be directly performed over the tool. And once the simulation is performed, we have done the simulation, we have got the results. We can again bring that particular results in Simpleware and visualize the same. Now, next up is the software installation, and the next part that we would be discussing in the next session. But to give a summarize, we have the support for both Windows system as well as Linux system for a research-based license. Configuration of the license is quite simple in Simpleware. It comes as a floating license, and at a time, multiple. So what is at a time only on one screen the software can be used, but the installation can be done on multiple systems. Also, we are accompanied by various plugin setups for enhanced capabilities, that is the advanced scripting options that we cater to. In the advanced scripting option, this part I will be further discussing in the detail. While after we have done the installation, we have done the pre-processing operation, how to use the scripting option, as it basically eases out of workflow while we are working on any specific part. Next up is the environment setup. While we are setting up environment, there are certain uh, important options that we need to be considered on. So, as discussed, in the external models, when we are doing the external models installation, there are certain environments that need to be set up, like a total segmenter installer, then a QNet model installer. And once we do that types of installation, we are set to go and work in the Simpleware software. We can also prepare workspaces for specifically segmentation task, specific base task. Then we can also work on any 3D printing workflows to be done directly. Now, taking an example how to import any CT MRI data in simple way. It's quite simple. When we are working with the data set, generally what we get is uh, mm, what we get is we have this import section option over here. So I'll use a laser pointer. Yeah. So here we have the DICOM images that comprises the CT, MRI, micro CT images, and for industrial images, that is for non-destructive evaluation, we can use the DICOM images section. If we need to connect the medical server, so hospitals have this PAC server option, so we can directly connect our system with PAC server and import the data set, so the confidentiality and anonymity can be kept in mind. Apart from that, we have the option of stack and raw images support, so we can bring in any JPG, PNG, TIFF data set. We can also bring in BMP images or any other raw image format that we need to work on. Next up, we have the 3D image import formats, wherein we can bring in analyze image, interfile image, meta image, directly .hdr image, .hpm images. Then SQL and CAD file, we have the support of .sql file, .obj file, .step file, and .iges file. And in the case of volume mesh file, we have the support of any CDB, IMP, VTK file. So any simulation file that we need to bring in, we can do that. Now coming on to the part of importing any DICOM file. It is very easy. What we generally do is we select out the folder that we need to work on. Here, I've shown an example of file which will be demonstrated in tomorrow's session. So you can have an idea. So we click on this DICOM images, then we can click on the scan folder. One more best option that we have in Simpleware is it comes with detailed uh, examples that we can directly work on. So it has a huge library of CT dataset, MRI dataset that we can work and learn the software on. So whenever we are importing the dataset, we can check the mobility, whether the particular data is a CT image or if it's an MRI image. So the mobility that would be written would be an MR. The total number of the slices, that is a slice is basically a set of image, and once we take a stack of images, so it forms a 3D image reconstruction for the same. We can also ensure that the particular voxel calibration is proper, not in the advanced import section that I will be further showcasing. And all the DICOM data tags, the patient information, the name, the date of the scan at which the scan was taken, the time of exposure for the CT, all is visualized over here. We have an option of anonymizing this, so even if we are sharing this data set with any other person, and we need to keep the confidentiality of patient in mind, so we can do the same here. Since that particular Statistically 279, so we can see we can move the particular uh, cursor over here, slider over here from all the way from 0 to 279, and we can see the across images for this actual view. Now coming on to the segmentation workflow. Segmentation workflow is quite simple when we are dealing with a semi-automated segmentation or automated segmentation. So here we use a threshold-based approach. Once we use a threshold-based approach, here we get multiple options in the threshold window. We select the grayscale region. Here it is selected as 189 and upper value being 1934 for this ankle city dataset. Once this is the ankle input is segmented out, uh, we need to click on apply over here. And once we have applied, we can do the semi-automated segmentation for the same. Here we can also isolate key features. We also have the same for uh, automated segmentation. So here, whenever we are doing the segmentation of the region, so for the same mass that I had shown earlier, we have further split it down into calcaneus bone, tubula, talus, and tibia, and further the particular parts that we have identified are marked over here. Then, if we are only interested in tibia, we also have further options. We can change the opacity. Then we can also change, or we can isolate this particular part out, and we can work on it accordingly. And coming on to the thresholding and filtering option, here in the threshold tab, it is shown in detail how we can use a histogram. Then we have a profile line approach. That is the best approach if we need to work on any soft tissue part, why we use the particular profile line approach. This all will be discussed in the second session that will be starting from 2:30 p.m. and all the CTP sets that are available, I'll be showcasing in the particular session. Here we also have, once we have segmented out, we can label the particular different segmented region. Once we have converted this particular part, we can also emboss the text over it. So we can see, we can, once we have done the 3D printing, we can emboss, we can work on the embossed text, and we can highlight the different parts if we are not that familiar with the anatomy of the patient. We can assign different colors, we can assign different names for each and every part, and then it can be used for clinical validity, obviously. Now coming on to the meshing preparation. So this is one such example in which an implant was taken over a femoral bone, and then a combined AKE model was created. And to over here there were cavities and porosity present in the bone. To generate a high quality 3D printable model, we have filled out the bone, we have filled out any small cavities that were present, and ultimately worked on our data set. So, summarizing whole session in this presentation, what we have discussed. So, Synopsys Simpleware is a complete suite. Here we can directly learn for any 3D imaging and scaling concepts. We can also work on any segmenting data. We can do the pre-processing of the images, and it comprises of a large section of data set. So, if we need to do the segmentation and processing, that can be carried out. If we need to do the measurement analysis, that can be found over here. Then to visualize the data set to check for the volume rendering, that is covered over here. Any CAD image and CAD and image integration. So even if we are working in implant and we need to integrate with the image data, that can be worked over here. And last up is the scripting and automation feature that we generally work on. If any specific part needs to any API script is needed, we can use this scripting option. So now I'm opening this session for question and answer and discussion. If anyone has any question, they can write up in the chat box. Also, if any questions will be further pending, we can cover that the same questions in the upcoming session from 2:30. So if there are any questions, please let me know, or you can also write the queries to my email as well as my contact number for the same. Yeah.
Yes, please. If you have any questions, please write it in. Is anyone speaking? Because I'm not getting the voice clearly. If you have any question, please write it down, or you can ask him right away. And one more thing I wanted to ask Ayush, it was a very informative lecture for sure, and very well demonstrated. One thing I wanted to know what because in the second session we are trying to keep it as a hands-on or a practical session. So how can we do that? Is this software available or any other software available for that purpose? Or the student version is available for the participants?
Actually, ma'am, we do have the evaluation version, but to get the approval for evaluation version, it takes around 2 to 3 weeks. What we can do is, I'll show a detailed demonstration of the same, and the participants can apply for the evaluation copy. Once it is approved, they can practice on the software, and meanwhile, if they have any queries, I'll be very glad to help them out for the same.
Okay, thank you so much. So please provide all the details and
Sure, ma'am.
participate. I'll request everybody to please go for the details and you can apply for the demo software so that you can do the hands-on right away. So it will be helpful for you. Otherwise, it will be very difficult to recollect and do it afterwards. So, Ayush, I request you to please provide the details in this chat box itself.
Actually, ma'am, there is an evaluation portal. That's an
Okay.
official evaluation portal of Synopsys, and
ठीक है
it
आप
takes
इसके
some
links
time
provide
for
कर
the
दीजिए.
evaluation version to be
नो इश्यूज नो
given out.
इश्यूज जस्ट वो लिंक दे दीजिए अभी नहीं तो 3 दिन बाद 4 दिन बाद जब भी हो
Yeah, yeah,
सके
it
पॉसिबल सो दे
it
कैन
can be done.
डाउनलोड इट या
So, what we need to do is I'm just sharing the link. Register over there on the Synopsys evaluation portal and
ओके
apply for evaluation copy of Simpleware software.
ओके
So
ओके
I'm just
थैंक यू सो मच
sharing the link.
एंड द
Just,
सेकंड
just give
सेशन
me.
इफ एनीबॉडी हैज एनी क्वेश्चन प्लीज राइट इट डाउन or we are having next session which is a practical session demo session and it is starting from 2:30 p.m. onwards, so I'm looking forward for the active participation. Please join by 2:30 and if you have any question please drop it here in the chat box. We'll use in the same link.
So there's a question from Dr. Javi. Yes, sir, we do have certain papers that tells us its accuracy compared to other softwares that are present in market. After this session, you can contact me. I can share you the paper links, how this particular segmentation software uh, is performing compared to various other segmentation softwares that are present. I'm just sharing my email. Let me share my screen. There's some issue with my chat box. Okay. So this is my email. ayush@ims-india.org. You can contact me over here and I can share you the related publications for the same. So thank you, ma'am. I think we can connect over at
And
2:30.
join you at 2:30 p.m.
Sure, I'll be
Okay,
joining.
thank you so much.
Thank you, ma'am.